confidence intervals, and sample size for a proportion. Let's go ahead and get right into the notes. Let's find the confidence interval for a proportion. In a recent USA Today snapshot, stated that the percentage of respondents who have had someone walk into them is 36%. 36% represents a proportion of cell phone users. The parameter is the proportion of cell phone users who had someone walk into them. The sample size was 738. The proportion represents the part of the whole group that can be expressed as a fraction, decimal, or percentage, or represent a probability. For instance, if a cell phone user is randomly selected, the probability that they have had someone walk into them is 0.36. Let's take a look at some symbols in proportion notation. Typically, P equals to the population proportion. P hat is typically the sample proportion. And for a sample proportion, we get P hat equals to x divided by n, Q hat equals to n minus x divided by n, or rather, Q hat is going to be the complement to P, where x is the number of sample units that possess the characteristics of interest, and n equals the sample size. Also keep in mind that Q hat is the complement to P hat. Let's take a look at an example. For a sample size of 80, where we're looking for x equaling to 45, let's find P hat and Q hat. Well, P hat, once again, will be x divided by n. In this case, 45 divided by 80, which will be 0.625. To get Q hat, we simply subtract P hat from 1. In this case, we get 0.4375. Another way to do it is to simply take the sample size, subtract x, then divide by, again, the sample size. So that could be 35 divided by 80. You'll get the same answer as 0.4375. Confidence intervals. The assumptions that must be made to find a confidence interval for a population proportion are as follows. First, the sample must be a random sample. Second, the conditions for a binomial experiment must be met. If it's been a while, it might be wise for you to go back and relearn some items concerning binomial experiments. Also, the margin of error for proportions is as follows. These formulas are quite important, so please take note. We must also take note of the formula for a specific confidence interval for a proportion. Note here that the proportion P for the population ranges between these two values in this compound inequality. Once again, you should write this down and take careful note of what you see here. This will be very useful in future examples. Let's go ahead and do an example. In a CBS News New York Times poll found that 329 out of 763 randomly selected adults said they would travel to outer space in their lifetime if given the chance. Estimate the true proportion of adults who would like to travel to outer space with 92% confidence. According to this poll, X would be 329, or the number of successfully finding adults that say they would travel to outer space if given a chance. N would equal to 763, or the number of adults that were asked in this poll. So therefore, P hat would be 329 divided by 763, or 0.4312. Q hat would follow by subtracting from 1, giving us 0.5688. Next, since we're looking for a 92% confidence, let's go ahead and look up our critical z-value for when alpha equals to 1 minus 0.92, which is 0.08. We divide that by 2, we get 0.04. Go ahead, pause the video, take a look at Appendix A, Table E, and see if you agree that our critical value is 1.75. Once again, it's to your benefit to check this on your own and see if you agree. If you agree, then you understand how to find these critical values in the table, which is going to be a very important skill in this chapter and the next. Now let's go ahead and plug these values into the margin of error. Once we plug these values into the formula for the margin of error, we get 0.0314. Once again, pause the video here, plug these values into a calculator, and make sure you get the same value as I do. This value for the margin of error is significant because now I'm going to go ahead and add and then subtract from also the p-hat value we found earlier. This will give us our range of values for the population proportion, in this case being 0.3998 up to 0.4626. And now we have estimated the true proportion of adults who would like to travel to outer space with 92% confidence. Let's do another example. In a poll of 738 cell phone users, 266 stated that they had been walked into by someone using their cell phone. Estimate the true proportion of cell phone users who have had someone walk into them with 95% confidence. This problem is solved in a very similar fashion to the last example. I highly recommend that you pause the video here and try to solve for this yourself. That is to say, try to find the estimate or compound inequality of the true proportion of cell phone users with 95% confidence. Then confirm your results with mine. Here we begin with x being 266 and n being 738. Also, let's find p hat, which is going to be 266 divided by 738, which is 0.3604. We will also need q hat in order to calculate the margin of error. This case would be 0.6396. Next, also needed is the critical value. Once again, we have the 95% confidence value. So we take 1 minus 0.95 to get our alpha, that is 0.05, then divided by 2 to get our alpha over 2, which is 0.025. Looking up the value in Appendix A, Table E, gives us our critical value of 1.96. Using the appropriate values for the margin of error, we plug them into the formula, we get 0.0346. Now we go ahead and take this value and both add and subtract it from p hat in order to find our true estimate of our population proportion. By adding and subtracting to p hat, we end up with 0.3258 ranging up to 0.395. Sample size. To find the sample size needed to determine a confidence interval about a proportion, we solve the margin of error formula for the sample size n. Here, let's take the margin of error formula and go ahead and solve for n. By solving for n, we get the following formula. Here, remember to round up to the nearest whole number if necessary. With this in mind, let's go ahead and do an example. A recent study indicated that 29% of 100 women over age 55 in a study were widows. How large a sample is needed to be 95% confident that the estimate is within 0.03 of the true proportion of women over age 55 who are widows. We will note here that 29% out of 100 is a pretty simple 29. So we're going to go ahead and use x equaling 29 as our number of successes. Keep in mind, success here doesn't necessarily mean a good thing, as being a widow generally is not a good thing. It just so happens to be the event that we're looking for. That is to say, there are 29 widows in this group of 100 women. So in that case, p hat is going to be 0.29, q hat will be 0.71. Also, they already gave us E as 0.03. That is our margin of error. Once again, since they gave us alpha is going to be 1 minus 0.95, we get 0.05. So dividing 0.05 by 2, we get 0.025. Then looking it up on the table, you'll see that our critical value is 1.96, very similar to the previous example. Now, since we're looking for how large is the sample needed to be 95% confident, we're going to go ahead and use the formula that was solved for n a couple slides ago. So using that formula, that is to say, p hat times q hat times our critical value divided by E, quantity squared, will give us 878.87, which is rounded up to 879. In conclusion, the minimum sample size needed to estimate the true proportion of widows within 3% at a 95% confidence level is 879. Let's try another example. Now this example is just like the previous one. So I invite you to pause the video here and try to solve for this one yourself, this time with a 98% confidence. Hopefully you paused the video yourself, and if you did, let's go ahead and see if your results match up with mine. A federal report indicated that 27% of children ages 2 to 5 years had a good diet. How large a sample is needed to estimate the true proportion of children 2 to 5 with good diets with 2% and 98% confidence? Calculating p hat gives us 27 divided by 100, which is 0.27, q hat being 0.73. Once again, since we have 2% as our margin of error, we will use E equals 0.02. Alpha in this case will be 0.02, which happens to be a coincidence, which makes our critical value going to be 2.33. Once again, take the 0.02 divided by 2, we get 0.01, and look up the number 0.01 in our table. Pause the video and see if you agree that the critical value is 2.33. Plugging this into the formula that's solved for n, we get p hat times q hat times the quantity, critical value 2.33 divided by our margin of error 0.02, quantity squared. We end up getting 2,675.09. Now you'll notice the answer here is a bit funny because it's being rounded up to 2,676. You may think that why is it not rounded down since we have 0.09 after the decimal place? Well, because we're talking about children, we obviously need to use whole numbers. In conclusion, the minimal sample size needed to estimate the true proportion of children 2 to 5 with good diets within 2% at a 95% confidence level is 2,676. To round down to 2,675, it would undercut the 2% we needed at 95% confidence level and would not be sufficient. So once again, the answer is 2,676.